Okay, so today we're going to be learning about the phase shift of a graph. So the phase shift is a slide to the left or the right, called a horizontal translation of a trig function. Okay, so that's what a phase shift is. So in terms of what it's going to look like, you can see what's boxed in, y equals sine x, and then y equals sine of parentheses x plus pi over 2, and then y equals sine of x minus 2. So I'm going to cross that piece out there. We don't need that. So we've now got a new kind of formula, new form for our equation. So if we have y equals a sine, and then in parentheses bx plus c, we're going to come up with a phase shift, and I'm going to start referring to phase shift instead of writing it out as PS. So the phase shift is equal to what? Versus if I have y equals a sine or cosine b parentheses x plus c. So if I have the b kind of factored out and I just have x plus c inside, what is my formula for the phase shift? Okay, so let's, before we fill those in, let's take and look at the graphs of sine x plus pi over 2, and sine x minus. So go to your calculator. If you clear out your tan graph, put the sine curve in to begin with, and then do the sine of x plus. Now I'm in degrees, so I'm going to have to go with 90, okay, because I'm in degree mode, I'm pretty sure. Yep. So x plus 90. All right, and let's just, what I have it doing is drawing out that second one kind of slowly. So I'm going to go with zoom 7, and so it's just going to quickly graph the sine curve from negative 360 to 360, and then you should be able to see this is y equals sine of x plus pi over 2, or x plus 90. Isn't it actually looking like it's to the left of y equals sine x? So, you know, you might think that this plus 90, my hypothesis, would have been that this moves to the right. (90°). But what really happens is it moves to the left 90°. Okay? So then that would help my hypothesis on this one to go from that it moves to the left to actually moves to the right. And it does. From the original y equals sine x. Okay, so I'm going to go and graph these so we can actually see that movement. So for y equals sine x, I'm going to go 3 over and put my pi over 2. And you know what? This is awfully small, so this is what I'm going to do. I'm going to change how I'm doing this just a little bit. I'm going to go 30, 60, 90 like that. And then 120, 150, 180. 210, 240, 270. 300, 330, and 360. And then I'm going to go up 1, 2, 3, 4. Put a 1 down, 1, 2, 3, 4, and put a -1. so I can see this a little bit better. Okay, so my sine graph. Now, for my sine graph, I have skeleton points, okay? I should know that my sine graph is going to go like this. And I'm starting at 0. And I should realize that what I can do is take the period. So my period is, for sine, 2 pi divided by the frequency. So it is 2 pi divided by b, which is 2 pi divided by 1. Okay, so that 1 is I'm getting that 1 from the value there. So 360 degrees. Now, if you take 360 and you divide it by 4, you get 90 degrees. So if I start at 0 degrees for this first point, then the next point should be 90, and the next one should be 180, and the next one, I'm just going 90. So 0, 90, 180, this should be 270, and then I'm back to 360. So there's my curve, and I'm finding my skeleton points. Now, to get those points, again, take your period and divide it by 4. The period, again, means how long it takes before you complete one curve. And so I am completing a curve by 360, so if I divide that by 4, then I can go in increments of 90, starting at 0. So now I can go 0, 90, 180, no calculator needed. And I'll label that when I'm done. I'm going to go to a different, I think I'll label it, so blue is y equals sine x. Okay. But you might want to label it right on it. I'm going to go to now doing the phase shift. So, we looked at this graph. Let's figure out over here y equals sine of x plus pi over 2, which is just really 90. What is our amplitude? Amplitude of all of these is 1, okay? So our amplitude is 1. Our frequency is 1. There's nothing, there's a 1 in front of the x, okay? So that's our frequency, or you could put it out in front of it. Our period is the important one. That's 2 pi divided by that frequency. So it's just 2 pi. So 360 again divided by 4. But our phase shift is equal to negative 90. Because you are moving to the left 90, another way to state that is negative 90. Okay, that's the way that we would say moves left 90, by negative 90. So the phase shift being negative 90, this is where you start graphing. Now, unfortunately for me, I should have put this over a little bit. I need to have 1, 2, 3, 4, 5, 6 more spaces here. So I need to go 1, 2, 3, 4, 5, 6 spaces. So let me state then that this is negative pi over 2. So this is where I'm starting my next curve, and I'm going to be in green. I am going to say I'm doing the sine curve. So here's my basic sine curve. This is what it looks like, my skeleton points. So I'm going to put my first skeleton point at negative 90. That's where I'm starting. Then from there, 360 divided by 4, back up here, is 90. So I'm going to go and get these skeleton points, okay, from the starting, I'm going to go 90 degrees. So negative 90 plus 90 is 0. Then 0 plus 90 is 90. 90 plus 90 is 180. 1, 2, 3, 4. 180 plus 90 is 270. These are my skeleton points that are going to make up my graph that goes like this. Those are my 5 skeleton points. So I'm using these. I'm starting at negative 90, then I'm going to 0, and I'm up at 1 because that's the way the sine curve goes. Then I am going to 90, to 180, I am back down, and then I finish up at 270. So in green is the graph y equals sine of x plus pi over 2. It has been moved to the left of the blue graph 90 degrees, and you should be able to see that. Now let's take a look at the next one, which is y equals, so if we go back to our calculator, and we go down to y2, and we change that to a minus, and we hit graph, it should look like it's moving, it's gone, it's kind of slid the sine graph to the right. And it has. Okay, so let's take a look at graphing that. So over here, I'm going to look at in red. So y equals sine of x minus pi over 2, which is really x minus 90. What is my amplitude? My amplitude is 1. What is my frequency? That's also 1. You could have that frequency be on the outside here, or it's on the inside of the parentheses. Still, it's 1 in front of the x. The period is 2 pi divided by the frequency, so that's just 2 pi, which is really 360, and if we divide that by 4, we're going to increment by 90. Now, my phase shift, my PS, is the opposite of that, because it moved to the right 90, so my phase shift is going to be plus 90 degrees. So this is where we start the graphing. And then from there we go that 360 divided by 4, we go 90 from that to get our 5 skeleton points. So I'm going to start at 90. 90 plus 90 is 180. 180 plus 90 is 270. So I am just using this 90 I got by dividing the period by 4. 270 plus 90 is 360. And then 360 plus 90 is 450. So these are my 5 skeleton points that are going to be here, 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 down, and back. So it's going to give me that sine curve that I need. Okay? So now I'm going to start at 90. And then I'm going to go 90 from there. So 180, I'm up at 1. You have to know the basic sine curve. You kind of go the upward hill, then you go back down the hill, then you go, then I go down again. So there's 270, 360. Now to get to 450, that's 90 beyond 360. So if I go back to some more plotting over here. Remember, these go 30, 60, 90, so this is 2 pi, which is 360, so this value here is 360, okay? So 360, this is 390. Then plus 30 is 420. And then another 30 is 450. So this is 450 degrees. I'd normally put them up a little higher. So there's my 450. Now, in terms of radians, this 2 pi really, remember, is a 4 pi over 2. So the 450 is going to be 5 pi over 2. So this one was 1 pi over 2 is 1 pi over 2. Pi is 2 pi over 2. And then we have 3 pi over 2. And then we have 4 pi over 2. So it makes sense that this value would be 5 pi over 2. Okay? So 450 is where I finish my sine curve. So I connect my red, and I'm going to say that I did the red. That one is y equals sine of x minus pi over 2, and that moved to the right 90 degrees. Okay? All right, so now that should give us a formula. You should notice that we kind of just took the opposite of the value in the parentheses. So x plus pi over 2, actually the phase shift was negative 90. Okay? So for sine of x minus pi over 2, the phase shift is positive 90. So our formula for phase shift is, if the b is inside the parentheses, the frequency, it's going to be negative c over b. If the b is factored out, which is your frequency, then it's just negative c. Okay, so let's take a look at some examples. So for cosine of x plus pi over 2, the phase shift is, the b is, just out here as a 1. So your phase shift is just negative 90 or negative pi over 2, because you're going to go 90 to the left. For number 2, the phase shift is, again, you're going to go negative, you're going to move to the left 60, or to the left negative pi over 3. You're going to go negative pi over 3. This is where you're going to start it if you were going to graph it. And then the phase shift for the last one is positive pi over 6, because you're going to go to the right. Now let me add a couple more on here. So let's say I have a number 4. Y equals sine of 2x plus pi. So for that one, the phase shift, okay, the 2 is on the inside, so it's going to be negative c over b, so that's going to be negative pi over 2. So that's the phase shift. You're going to start at negative 90. Number 5 example, let's say I have y equals cosine 3 parentheses x minus pi over 4. So when it's been factored out, then the phase shift is just equal to the opposite of c. Because if you were to distribute that 3 back in, it would be 3x minus 3 pi over 4, and then you'd have to do 3 pi over 4 divided by 3. You'd just get pi over 4. So the phase shift, when it's already factored out, is just the opposite of negative pi over 4, which is pi over 4. And then down below here, it kind of gives you that formula again, negative c over b. But if the b is factored out, then you can just do negative c. Okay, let's go to the next page. So the next page says to do this, sketch the graph of this phase shift. And there's amplitude and there's frequency. Now, I'm not going to use my calculator. If I were to use it, I would be in degree mode. And I would type in 2, because you can't type in the 2 the way it is. So I'd type in 2 cosine. And when you do that, it gives you a parenthesis. I would type in 2 parentheses x plus, I guess this would be 60, and close the parenthesis like that. And then if you are doing it in the calculator, you have to get maxes and mins. and you need to look for a complete curve. So I'm going to show you how to do it without the calculator. It's quite simple. And then we'll go fill in the window after that. The amplitude is that height. Okay, here's your amplitude. All right, and here is our frequency. So our amplitude is equal to 2, and our frequency is equal to 2. Now, the period is 2 pi divided by b, which is the frequency. So that is 2 pi divided by 2, which means that we only need to look at graphing 2 pi, or 180. We're going to get one complete curve in 180 degrees. Now, the phase shift, because the 2 has been factored out, is just the opposite of c. So that's negative pi over 3, or negative 60 degrees. So this is where we're going to start our graph. Okay? Now, to figure out our skeleton points, you can take that period, which is 180 degrees, and divide it by 4, and that gives you 45. Now, when you take that 45, you're going to start at negative 60, so I'm going to list out my key points here. Then I'm going to take and add negative 60 and 45. Okay, so negative 60 plus 45 is going to give me my next key point, which is negative 15. And then I'm going to take and do negative 15 plus 45. And that's going to give me 30. And then I'm going to take 30 plus 45, and that's going to give me 75. And lastly, I'm going to take 75 plus 45, and that will give me my last key point, which is 120. So when I go to graph this, okay, this is going to be the high point, then I'm going down, going back up, and up to the top. So this is what my cosine curve is going to look like. And these values are the degree values where those key points are located. Okay, so to graph this, what we're going to do is the same thing we did on the last one. I'm going to do, I need negative 60. So I'm going to have, this is negative 30, this is negative 60. So here's negative pi over 2. And then this is going to be 30, 60, 90 on this side because the blocks are so close together. And then this would be 120. And I need to get to the period, which I need to get to 120. Well, there I am. So at the top here, if you're like, you know, this is 120. This is our 90. This is our 60. And this is our 30, negative 30, negative 60, and negative 90. So I'm going to take my graph and start it at my key point, which is negative 60. So here's negative 60. Now, I need to look at my amplitude is 2. So I'm going to go up like this for my amplitude. I'm going to go 1, 2, 3, 4, and 1, 2, 3, 4. Down 1, 2, 3, 4, and 1, 2, 3, 4. I'm just trying to make this look decent, so I expanded it a little bit. Just make sure that everything's equal on the x-axis and the y-axis in terms of, you know, if you go up 4 on the, you know, the top part of the y-axis, you have to go down 4 on the bottom. Same thing with the left and right. All right, so negative 60 is where I'm going to start this cosine curve, and that's right here. Here's the key point. So I'm going to start it at 2, which is my amplitude. There's no reflection over the x-axis. Then my next key point, if I look down here, is negative 15. So my negative 15 would be halfway between 0 and 30. So this is negative 30, so negative 15 is right here. And then my next key point, okay, so that was negative 60, negative 15 now is positive 30. So I'm going to go to positive 30, which is right here, and go down to negative 2, because it has to look like the cosine curve. And then 75. So if this is 60 and this is 90, 75 is going to be right in the middle. And then I'm finishing my graph at 120, and that's going to be up at 2. So that is one complete cycle of this curve, okay? I did not need the calculator whatsoever. If you're going to use the calculator, you need to find out what this minimum point is, what these maximum points are, and you need to have, you need to get those points. So you'd be doing second trace min and max. So you'd want to make sure your x min went negative 90, your x max went at least 120, so maybe 120 or 180. Your x scale, maybe you want to go by 15 or 30. I don't know, that's up to you, and then negative 4 to 4. But I am going to not use a calculator because it's easier. Just take the period, divide it by 4, and add it on to the phase shift where you start. All right, last two examples. Now, we are going to be asked to write the equation for each graph below. Choose the function with the smallest absolute value of the phase shift. So we're looking for the value that's closest to the y-axis. So is a sine curve or a cosine curve closest to the y-axis? In this case, I'd say maybe the cosine curve. So if you realize that a cosine curve has those skeleton points, there's the top of the cosine curve, and then I'd say it ends right here. Here's the bottom, and then here's where it's hitting, okay? So those are those 5 key points. So I'm going to go with y equals, I know that it's a cosine curve and its amplitude is 1, so I'm going to go 1 cosine. The frequency, you can see one complete cosine curve, it's just been shifted like one little 30 degrees over to the right, so the frequency is still 1. So I'm going to go with 1 times x, and then I need to figure out my phase shift. So I know that this value right here is 30 degrees. That's 30 degrees, or pi over 6. So it looks like it's been shifted to the right from 0, that pi over 6 amount, or that 30 degrees. So it looks like it's been shifted right 30 degrees, which is pi over 6. Now, shifted to the right means the phase shift, okay, so that means the phase shift is positive pi over 6. But when we put it in the equation, we have to do negative, because the phase shift formula was negative c. So it's going to be minus pi over 6. Okay. Number 11, it looks like it's just a cosine curve already, and it's just been reflected over the x-axis because, look, I can see the 5 skeleton points of a cosine curve starting at 0. So when you start at 0 for the, the skeleton points, you have really no phase shift here. So this looks like y equals, the amplitude is 1, but because it's been reflected, it's negative 1 of a cosine curve. Now what I need to do is figure out what the frequency is. So the frequency is the number of complete curves from 0 to 2 pi. So number of complete curves, but I'm just going to put curves from 0 to 2 pi. Well, I'm seeing one curve by pi, so how many curves would I see by 2 pi? I believe I would see 2. Okay, so it's just going to continue to do this out here to 2 pi. So our frequency is 2. And that's that one. There really was no phase shift on that. You could write it using a sine phase shift, but if you were taking a Regents exam, I don't know why you would. You'd want to write that. Okay, that concludes the lesson for today.